Last week we started the topic of traffic control devices. Okay, so traffic control devices are any media through which we communicate with the driver. Okay, any traffic regulation, any warning, any information. Okay, anything related to the driver is communicated through a device, and any such type of device is known as a traffic control device. Okay, traffic control device has three main types, which are, what are the types of traffic control devices? Signals, signs, and what else? He's very shy. Markings. Marking. People who we feel are very shy, they are very, how to say, they are the other way around, if you know them. I have a daughter like this. The teachers in the class say she is very shy. They are thinking that we'll take a video of her and send it to our teacher. Okay, so and then there are subtypes for each one of them. Okay, so signs have subtypes, markings have subtypes, and traffic signals have subtypes. Okay, and then there are any sign or any traffic control device to be effective, it has to fulfill certain requirements. Okay, it should be provided only where there is a need. It should command attention. It should be conveying a clear and simple message. It should be providing enough time for the drivers. Okay, and it should be encouraging the driver to use them. Okay, so they can see what will happen if they don't use them. Okay, so these are things which we discussed earlier, along with these couple of points related to signals. So the main point was, once a signal is installed, it cannot be turned off. Okay, signals provide more capacity at the intersections. They reduce number of severe crashes at the intersections, and they also provide the chance to make continuous movement along the highway without a stop. If you have signals in a series, then also signals can be programmed together. Okay, so a particular driver may not have to stop at all when they are passing through this series of intersections. And the last thing was, signals also make sure that minor movements, drivers who are coming from the minor road or pedestrians, they also get sufficient and safe chance to cross the road. Okay, so these are some of the things which make the signals more appealing. Signal indications, mainly there are three indications, right? Signal has three lights, right? And those lights are called as balls because of the shape. Okay, in fact they are totally round. If you take a signal light out and then you are not arrested, then you can see that even from behind it is like a ball. Okay, so we know there are three lights, right, which are red, yellow and green. Okay, red, very easy. Green, very easy, right? Yellow is for go faster, very good. Huh? What does it mean for the driver?
You can pass fast.
You can pass faster. Everybody agrees, right? Yes. Slow down. Different planet, different planet. Huh? So it's move with caution. Caution, everything, for everybody is something different. Huh? Caution, the word caution or care For everybody it means something different. Moving very fast. Okay, I'm going very carefully. Right? So I make sure I will pass before the signal turns red, right? Okay, but it means move with caution. And in the book, when they are talking about yellow, it is yellow between green and red. Transition from green to red, that yellow. Okay, we have yellow for transition from red to green as well. That is not critical. That is not considered critical because drivers are already stopped. Okay, so the critical one is when the drivers are moving, that yellow. Okay, so what do they decide at that time? They already stopped, obviously. The only decision is to move. Okay, if you know the amount of yellow, the critical yellow, you can give it the same for the non-critical one as well, no problem. Okay, so if you feel 3 seconds of yellow is enough for transition from green to red, then it is also enough from red to green as well. Okay, and that, that yellow does not, if the traffic is already stopped, it does not mean anything. Okay, you move, that's it. Yes or no? Okay, but the other one, the critical one, okay, it can, the action of the driver can vary. Okay, the start of yellow, the drivers may be thinking something different. The end of that yellow, the drivers may be thinking, maybe taking some other decision and so on. Okay, so that's why it's important. And then we have the flashing ball. Flashing, we use again flashing green as well, right? So flashing green is before yellow. Okay, so it's just like an extended yellow time. We know the signal is about to, the green is about to finish, right? So flashing green is just like an extended yellow time, and it does not keep on flashing, right? Flashing green then yellow. Okay, what they are talking about, flashing ball, is continuous flashing, no change. Okay, and that is done either for yellow or red. So continuous flashing yellow or continuous flashing red. Continuous flashing yellow we have. On some locations we have continuous flashing yellow for pedestrians crossing, for curvatures and so on. It means what? Be careful. Okay, so it's like a give way or a caution sign, a warning sign. Okay, so flashing yellow is just like a warning sign or a give way sign. So you can pass, but with caution. Flashing red, I haven't seen it, but I haven't seen it here. But in Karachi they use it. Flashing red means it's like a stop sign. Flashing red is like a stop sign. So you come and you stop, just like you do at the stop sign. You may say we don't stop at the stop sign as well. So yeah, fine. Keep on moving, no problem. Okay, but you get the idea. Okay, and then we have some signals which have the same lights, red, yellow, green. Okay, but these are not just lights. These, within the light we have a arrow sign as well. Okay, so the arrow indication means what? For this direction. Okay, so the arrow indications are indicating the direction for which the signal has become green or yellow or red. Okay, so if you want to separate the movements, then you use the signals which are showing the movement as well. Okay, so if you show a simple green, okay, without any arrow, it means okay, everybody from that direction will move. Okay, but if you use a green with a straight arrow, that means just green only for straight. Okay, sight distances for signals, recommended values, and they are coming from the speed. Obviously, sight distance depends upon speed. Okay, and they are also using some other constants as well. We will talk about them if time permits. But these are the standard values. So the speed increases, the sight distance should increase. drivers who are coming at high speed, they should be given more time to stop or decide. And this was also one of the requirements for the traffic control device to be effective. Okay, giving them enough time. Okay, so more distance, more side distance gives them enough time. Okay, some more terms related to signal design now. Okay, so these are the terms which are related to signal design. So the first term is cycle length or cycle. We have used it in delay studies and intersection countering studies as well. Cycle means what? Two wheels, two pedals. Huh? What? Okay. Yeah, anyone else?
Cycle for one full movement.
Yeah, one full cycle of all movements. Yeah, okay. And if you say end of green, then you are not considering the yellow. When you say beginning of red to end of green, after end of green we have yellow, right? Yellow is part of the cycle. Okay. Red to red, but the beginning. Okay, so the beginning of red till the beginning of the next red. When the next red begins, there's the end of the cycle. Okay, but during one cycle, all movements receive their time. They're green, they're yellow, they receive them. Okay, and the cycle length is the time which is taken by one cycle, the number of seconds. So cycle length is represented with capital C. Then we have an interval. So within one cycle, we have multiple intervals. Okay. One interval is the time during which signal lights indications remain constant. They don't change. Okay. So for example, the signal just became red. Now till it remains red, it is one interval. From red it will go to green or yellow, whatever. So that is the end of red and the beginning of the next one. So if it becomes yellow, it is the beginning of the yellow. Until it remains yellow, this is yellow interval. Got it? Okay, so we have green interval and red interval, and okay, we have yellow interval. Yellow interval is called as change interval as well. Change interval, yellow means the same thing. Then we have clearance interval. Another name for it is all red. Okay, and I found that everybody knows about it. Okay, so it's an open secret. All red means what? The interval of red. But why would they say all red? Because all movements have red. And this is which time? When does it happen? All movements have red. Between two movements. Okay, so one movement finishes. Okay, it has the yellow finished. So now it has red. But that doesn't mean the other movement will immediately have the yellow. When one movement starts is red, the next one does not start immediately. So there is a small amount of time when the previous movement has red and the next movement has not started yet. So this is all red. The movement which just had the yellow, it has finished. So it is showing red to them. And the next one which is supposed to start, still red. Okay, so we call it what? All red. Clear? Okay, so why do we give all red?
To give a chance for the who became red to move.
To make sure drivers who are already in the intersection, they clear. This is why we call it clearance interval. The drivers, when they are passing, they don't know the yellow. How much of the yellow is left? Okay. So some of the drivers may cross, or they already decided, okay, when I reach, it will be yellow. Okay? Because there is a time in which you can decide, right? You cannot just decide at the stop line whether I should stop or not. Even if you decide, you cannot. So you have to decide earlier. So you decided I will cross, so you will cross now. Okay? But maybe the signal has become yellow. Okay? So for those drivers who made this small error or did it intentionally, okay, see yellow, go fast. So for those drivers to clear the intersection, okay, so we call it clearance or all-red interval. And then we have the phase. Phase is a combination of three intervals. Phase is a combination of three intervals: green, yellow, all red. Green, yellow, all red. Okay, the total time of a movement. This is called as a total time for one movement. Okay, signal becomes green, movement started. Yellow, it can continue. All red, it is supposed to clear. Okay, so total time given for one movement is a phase: green, yellow, and all red. Okay, signal can be operated in three ways. Yeah.
What is the difference between phase and cycle?
A cycle is a combination of phases. The cycle is for all the movements. Phase is for one movement. Okay. So a cycle has multiple phases, and each phase has three intervals. Which one? Yes. Okay. Then the signals can be operated in three ways. You can have pre-timed signals, semi-actuated signals, or fully actuated signals. Pre-timed means the signal timing is fixed by the operator. Okay, it does not take into account the real-time data. Okay, so there are no sensors, there are no detectors attached to the signal. Whatever timing you fix, the signal will operate according to that time. Okay, but as the operator, you should know that the traffic does not remain constant throughout the day. So when we program the signal, we don't program the signal for one timing. Okay, so we've set a timing for morning peak hour, we set a timing for afternoon peak hour, we set a timing for evening peak hours. Okay, so these timings can be different. The intervals can be different, the cycle length can be different, and so on. Got it? Okay, so pre-timed signals are programmed by the operator to operate according to the prevailing traffic conditions. Okay, but those conditions are already estimated. Okay, they have nothing to do with the actual traffic data. So for example, the signal is operating pre-timed, and for one of the highways they started some maintenance work. So obviously from that side you will have less traffic, but the signal will keep on operating on the same programmed timing until you change it yourself. Got it? Then we have semi-actuated. Semi-actuated is attached with a sensor. It is used at the intersection of a major road with a minor road. Signals are for intersections, right? Intersections between two roads. So semi-actuated is used where you have a minor road intersecting with a major road. Okay. One of the roads will have a sensor, will have a detector. The other one will not have it. Which one should have the sensor?
Minor.
Why minor?
Less traffic.
Less traffic. So what will happen?
It would be given the chance just if the traffic is there.
Yeah. The major road is supposed to have more traffic. So it's supposed to take more time. Okay. So the time to minor road is only given on need basis. If there's a need, it will become green. Otherwise, it will remain green for the major road. Got it? Okay. So sensor on the minor road only, semi-actuated. Then we have fully actuated.
No,
Huh?
no minor and major,
All
all have sensors.
have sensors. Okay. So it is used mainly at the intersection of two major roads. 2 minor roads, we can make it free time, no problem. Traffic is less. Okay, but for major roads, especially when the intersection is between two major roads, fully actuated signal will provide better efficiency. Okay, so it will give timing to all movements according to real time traffic. Okay, whenever you the traffic from any movement increases, the time for that movement will increase. Okay, so in fully actuated signals, the time of one interval can change, the time of one phase can change, and the entire cycle length can also change. Got it? Okay, in fully actuated signals, or any time can change from the minor interval to the entire cycle length. Okay, but pre-timed, as I told you, fixed. Clear? Okay, signal coordination I already mentioned in the last lecture as well as today as well, that you have a sequence of signals which are very close to each other, sequence of intersections all having signals, they are very close to each other, so you program them so that the vehicles move without any interruption. Okay, but you can only do it when there is a major road and the other roads are, the intersecting roads are minor roads. Okay, for example, the 16 December highway, the one which is passing in front of the stadium. So all the other roads are minor roads. Okay, 16 December is a major road. The others are streets. Okay, normally having less traffic. Okay, the other example I have mentioned here, yeah, Nasan highway, Defa. Again, so the main highway is this one, and the streets are minor streets. Okay, because you want to give preference, right? I want to make sure the traffic on the major road is going uninterrupted without stopping from first signal to the last one. So what will happen to all the minor roads? They have to stop. So if the other roads are also major, cannot do this. Both are major roads, then you cannot do this. Okay, so coordination is applied on a major road which is intersected by series of minor roads, and the purpose is to make sure that vehicles move without stopping. Okay, the other condition is these signals should be close to each other. Okay, signals which you are trying to coordinate, they should be close to each other. Okay, if one signal is not here and the other one is after 5 kilometers, don't need to do any coordination, because in this 5 kilometer a lot of changes will happen. Drivers will slow down and accelerate and whatever. So when the signals are very close to each other, then all vehicles will approximately reach the next signal at the same time. But if the spacing between the signals is too large, the vehicles will move according to the drivers. Some of them will keep on changing lanes, some of them will go very fast, some of them will go very slow. So they will arrive randomly. So we cannot do coordination. Okay. So the signals should be close to each other. It should be a major highway crossed by a series of minor streets. Got it? Another condition is when you have decided I will do coordination for all signals which are coordinated with each other, they are linked with each other, their cycle length should be same. So if I coordinate 4 signals together, for all the 4 signals I should have the same cycle length. Okay? Otherwise again coordination will not work. We are not doing the calculations for coordinations, but just keep in mind it will not work. Okay? Now what do I need to know to do the coordination? The vehicle arrives at the first signal. I make it green. Okay? The next one, when should it become green?
In the first pass.
Huh?
After you read,
Yeah. After that vehicle reaches the next one, right? Okay. So you will calculate this time. This time is called as offset. The time interval between the green of successive signals, we call them offset. And how do I calculate the offset? I should know the distance between the two signals and the speed. Got it? Okay. Okay, what is headway? What is headway? No, it's time. Time. Time interval between two vehicles. Yes. Okay. The time interval between two vehicles to pass a common point, which is measured for a common reference for the vehicle as well. Okay. So how much time interval between two vehicles when they are crossing a point? Okay. We call it what? Headway. And saturation headway is the minimum headway when two cars are passing from the stop line of the signal. Saturation headway is the minimum headway between two cars while they are crossing the stop line of the signal. Got it? Okay. So headway is time interval between two cars for any point, crossing any point. When we say saturation headway, that point is what? The stop line. They are crossing the stop line at the signal. And the value is minimum. Okay. When you take inverse of headway, it becomes inverse of headway speed, because it's S, right? It must be speed. Spacing also comes with S. Very good.
Time, one unit of distance, where's the distance in their time?
Distance, where is the distance? When we talk about distance, there is no
Spacing.
You already said that. Huh? Vehicles per hour? Because written? Where? It's not written here, right? Vehicles per hour. Okay, vehicles per hour. Vehicles per hour is what? Yeah, flow. Okay, flow. Why they have written as? Because it says saturation flow rate now. If you take the inverse of saturation headway, you get saturation flow rate. Inverse of saturation headway gives you saturation flow rate. And what did I say about the value of saturation headway? It is minimum. So inverse of minimum is maximum. So saturation headway is the minimum headway, then saturation flow rate is the maximum flow rate. Okay. You can see the definition over here. It is the maximum flow rate for movement of vehicles from a signal with 1 hour of green. Okay. Can you have 1 hour of green? No. Okay. We don't have. Don't live in heaven. So we don't have. So it's a theoretical value. It's a theoretical value. That's how we calculate from headway. You cannot directly go and measure saturation flow rate. Okay. So saturation headway, minimum headway between vehicles crossing the stop line of a signal. Saturation flow rate, the maximum flow rate of vehicles passing through a signal with 1 hour of green. Okay, continuous. Okay, how do we, so we cannot measure saturation flow rate, but we can measure saturation headway. Okay, how do we do that? You simply note down the time between two vehicles when they are crossing the stop line. So the first one crossed, after how much time the second one will cross, after how much time the third one will cross. Okay, Now, the first vehicle of the queue, okay, will it take more time to cross or less compared to the other vehicles in the queue? So there are 10 vehicles in the queue, right? If you go from the first to the last, which will take the highest time to cross? The first one, because it's a slower one. Okay? The first 2 or 3 vehicles, when the signal becomes green, they have to get ready, they have to put their phones away, right? And obviously when they cross the stop line, they are slower. Okay? So the interval between them is higher. Okay? As you go down the queue, so for example you measure the queue between first 2 vehicles, it will be some value. Between the next 2 vehicles, less. Next 2 vehicles, less. Okay? So as vehicles from the back of the queue, they arrive at the stop line, their headway becomes less. Okay? So this is what it looks like. This is the headway at the start of the queue. As the queue keeps on moving, the headway keeps on decreasing. Okay? Will it become 0? No. 0 means what? Accident. Okay? So it will reach a minimum value. And what do we call this minimum value? Saturation head. Got it? Clear? So we can measure saturation headway, just have to observe the queue, and whenever you reach the minimum headway between the 2 vehicles, that is the saturation headway. Okay? But obviously these headways are random, so we take an average value. Okay? And they have found that this minimum value is usually after the 4th vehicle of the queue, 4th or the 5th. Okay? So the first 3-4 vehicles in the queue, they have longer headway than the other vehicles. You attain the minimum value from the 4th or the 5th vehicle onwards. Okay. When you compare between the saturation headway and the headway of the first 3-4 vehicles of the queue, the first 3-4 vehicles have more, right? Their headway is more. Okay. So when you take the difference between the saturation headway and the headway of the first 3-4 vehicles, their difference is known as startup loss time. Okay, so startup loss time is the extra headway which is consumed by the first 3-4 vehicles in the queue. Extra meaning in comparison to saturation. Okay, got it? So obviously there will be some startup loss time for the first 2 vehicles, then startup loss time for the next 2 vehicles, maybe startup loss time for the 3rd set of vehicles as well. So there will be 3-4 values, right? If you add all these values, you call it startup loss time for the phase. Okay? So we have a minimum headway. The first 3-4 vehicles in the queue, their headway is more than minimum. So whatever extra value they have is called as startup loss time. And if you add the startup loss time of all the first 3-4 vehicles or set of vehicles, you get the startup loss time of the phase. Okay? And what is the phase? Which interval? Green, yellow and orange. Okay? So every set of these intervals has a startup loss time. Okay? It is represented by L1, small l1, and it is a summation of the delta. Delta is what? The difference between the headway of the first few vehicles and the minimum. Okay? Every phase has 2 loss times. One of them is what? Startup loss time. Okay? The other one is called as clearance loss time. I already explained it, right? What is clearance loss time? What is clearance loss time? I explained clearance interval, right?
Extra time taken by the driver to leave the intersection.
Okay. Anybody else?
It will become red, then this time until the movement is stopped, it's the clearance loss time.
Until the movement is stopped. Movement is already stopped. So when one movement is stopped at the stop line, and the next movement begins from the other point, for the other phase, that is the clearance loss time. Got it? What was clearance interval? All red, right? So all red was what? One movement stopped. The other one also stopped. Okay? So clearance loss time is the loss time between two movements, basically. The end of one movement and the start of the next one. Okay? So every phase has two loss times. Startup and clearance. The startup happens when the phase starts, and clearance happens when the phase ends. The all red is the end, right? Okay, so startup loss time, when the signal becomes green, first 3-4 vehicles move slowly, they take more time, the startup loss time. When the phase ends, we stop one movement but we don't start the other one. Okay, so that is clearance loss time. Clear? Okay, if you add them together, you will get the total loss time of one phase. Okay, one phase. Okay. Okay, then we have the term effective green. There's an actual green and there's an effective green. Actual green means what? When the signal is showing you green light, that is actual green. Okay. Effective green is the green time and capital Y. This is capital Y. Okay. Capital Y includes small y plus AR. Small y is yellow and AR is all red. Got it? Okay. Small y is yellow only. Capital Y, yellow and all red, both. Got it? It is because of these things that everybody doesn't get an A in this course. Otherwise, everything is very easy. They are trying to make it confusing. I'm very happy with it. Okay. So, green plus capital Y. Capital Y means yellow and all red both. So, green plus yellow plus all red. What does it make? Green plus yellow plus all red. Phase. So, phase, time of the phase minus total loss time of the phase. And the total loss time has two parts, right? What? Startup and clearance. Okay. We have a sample problem. We can solve it in two ways. Okay, we will look at both of them. How we can use the cycle time and the loss time to calculate the capacity of a movement. Capacity of one approach of the signal, one side of the signal. Okay, so we have a signal which has 60 seconds of cycle length. We have green time of 27 seconds. Capital G. Capital G means actual green. Actual green. Okay, and then we have an effective green as well, which is this one. This is effective green. Actual plus yellow plus all red minus loss time. This is effective green. We present it with small g. Okay. Yeah. One thing. What happens during effective green? During effective green time, the vehicles are supposed to move or cross the stop line at saturation headway. During effective green time, the headway between the vehicles is equal to saturation headway. Okay, so the flow rate equals to what?
Maximum flow rate.
Saturation flow rate, maximum. Okay, so this is the definition of effective green. Okay, yellow plus all red, which is capital Y, 4 seconds. Saturation headway, this much. Startup loss time, clearance loss time for this movement or this phase is this much. Okay, like I said, there are two ways to solve this problem. We'll look at both of them. Okay, the first one is by using the total effective green time. Okay, how much is the cycle length? 60 seconds. So in 1 hour I will have how many cycles?
One.
How many? 60. Okay, 1 minute for every cycle. So in 1 hour I can have 60 cycles. In one cycle, how much effective green time I have? Effective green time in one cycle. So effective green time was, we represent with small g. It was capital G, capital G, minus plus this minus TL. Okay, the lost time. Green time how much? 27 seconds. Plus yellow and all red. 4. Minus lost time. Lost time has two parts. 2 plus 2. Okay, so 27 seconds. One cycle has 27 seconds of green. Okay, and 1 hour how many cycles? 60. So 60 into 27. 60 is the number of cycles you have, and 27 is the effective green in one cycle. Got it? How much?
1620.
Huh?
1620.
This is number of seconds you have of effective green in 1 hour. Number of seconds of effective green in 1 hour. Okay, and during effective green time, the vehicles move with what headway? The minimum headway during this time. So in 1620 seconds, the vehicles were moving at a headway of 2.4 seconds. So total time 1620. In this time, the interval is 2.4 seconds per vehicle. So how many vehicles?
600 something more.
This is what we will call as the capacity. How much?
675.
600 vehicles per hour. Okay, I knew the saturation headway, so I calculated the time in which saturation headway is applicable. Okay, and this one. Okay, so this is one method of doing it. Okay, the other method is by using the ratio between the green time and the cycle length. Okay, so effective green time you already calculated, right? 27 seconds. So what is the green upon cycle length ratio?
145. 0.45.
Okay. Now, what happens during effective green? What did I say? During effective green time,
Maximum flow rate.
maximum flow rate, and the headway is minimum. Okay. But do we have, so if I can have the whole cycle length in which vehicles were moving at saturation headway, then G by C ratio will be what? If vehicles move at saturation headway in the entire cycle length. So the entire cycle length is what? G. The entire cycle length is effective green. Okay, so this ratio will be what? 1. This ratio will be 1. Okay, but it's not 1, it is how much? 0.45. Let's say if it was 1. If it was 1, the entire cycle length was saturation was effective green. Then how much flow rate I can achieve? If in the entire cycle I only have effective green, nothing else, how much saturation flow rate I can achieve? How do you know that? Which equation? 3600. The equation says 3600 only.
The minimum headway.
The minimum headway. Okay. During effective green time, the vehicles move at saturation headway. And when the vehicles move at saturation headway for 1 hour, you get saturation flow rate. Okay. So saturation flow rate is, again, small s. What is 2.4? The saturation headway. If saturation headway continues for 1 hour, 1 hour is 3600 seconds, right? Okay. So if saturation flow rate or saturation headway continues for 1 hour, how much flow rate you will have? How much? 1500. Now come back to the actual situation. Can we have saturation flow rate? No, because the effective green is not the entire cycle length. It is how much part of the cycle length? 0.45. Okay. So instead of, like I mentioned earlier, if this ratio was 1, then the flow rate will be this much. But this ratio is only 0.45. So the actual capacity will be 0.45 of this one. Okay. Which would be, yeah. Okay, so two approaches. In the first approach, I calculated the available green time of 1 hour, effective green time of 1 hour. In that green time, I know the interval between vehicles is 2.4 seconds. So in the available effective green time, I can have a flow rate of 675. Okay. In the second approach, first of all, I calculated what is the maximum value I can have in 1 hour, which is 1400. But this value is hypothetical, is ideal. I cannot achieve it. This value can only happen if the entire cycle length was effective green, which is not the case. So this ratio will become 1. Okay. So since this ratio is not 1, so I cannot achieve this value. I will achieve a part of it. How much part of it? This much. It will be never 1. Unless you design it, but nobody should take it. Okay? Clear or not? Okay. So there are a couple of announcements which I put in the teams. There's a problem with the date. The date is 5th December. Okay.